Let's have a look at extinction fairly quickly. Extinction, by definition, is the death or disappearance of an entire species from planet Earth. This isn't, again, something that happens necessarily very quickly, but can take a long, long time. And a species can go from being having, many, many members in its populations around the world, or even in one spot. Then over time the numbers decrease, and it may reach a point of where we might refer to it as an endangered species. This is of course a human classification. And then it might be that all the remaining members of the species die out and the species becomes technically extinct. Sometimes there are species which we haven't cited members of for many, many years, and I think the working definition sometimes is if we haven't seen a member of the species for up to 50 years, then we can say with reasonable certainty that it's most likely extinct. Although every now and again you have written a species off, and then in a most obscure place a member of the species might crop up. But in terms of just pure definition, it is the death or disappearance of an entire species off the planet. There are two kinds of extinctions that are understood in evolution. There's what we refer to as background extinction. And background extinction just simply means the fact that there are many species over long periods of time that disappear due to just normal, natural causes. Slow changes in environments, or even slow changes in environments over time. The species, for whatever reason, can't sustain its populations, and ultimately all members die out and disappear. And there's kind of a general background extinction rate across Earth's history, and we can see that, say, in a graph like this one here. So your extinction rate that sits in the background. And then this particular background extinction process is punctuated with periods in Earth's history where we would describe what we call mass extinctions, where very large numbers of entire families of organisms disappear relatively quickly off the planet, usually due to some kind of catastrophic change in environment or the nature of the planet itself. This could be to things like an asteroid hit or a comet hitting the Earth, as illustrated in the artwork over here. It could be to the prevalence of supervolcanic action. It might be to do with climate changes, which have happened many times over Earth's history, where entire areas become too dry, no water. It could be sea level rises, sea level drops. So major environmental change where a species simply can't adapt fast enough to it and ultimately disappears. There are some very sad stories at the moment where some researchers have been either in the privileged or terribly underprivileged position of literally citing the very last member of a species of animal on planet Earth. And there's a wonderful story, or a very sad story, that Tim Flannery tells of a researcher who had studied a species of frog in the highlands of New Guinea for nearly 30 years, and each year watched the number drop off and off and off, until one year she went up into the highlands and discovered or saw one frog sitting in the breeding area, and she knew that she was literally looking at the last frog of that species on planet Earth, and knew that when that frog died, the entire species would be extinct. So to finish off this tutorial, let's just have a quick look at two more diagrams, and just to get the same idea again about background and mass extinctions. So here's another kind of graph which shows something very similar to the other graph, but almost kind of a little bit in reverse. So you've got kind of number of families is described here. Now remember, families is a classification category. So number of families, and this will be all in the fossil record. So they're basing this on the fossil record. But what they've circled, of course, are major extinction or mass extinction events at various points in history where there's been a significant drop in the number of families in the fossil record, which suggests some kind of catastrophic event at that particular time. And I think to finish off, this is not a bad diagram as a nice summary of the whole thing. So again, the bar width represents the number of living families, and you can see over time that there is kind of divergence in evolution as more and more species kind of evolve on the planet, but every now and again you get this drop-off in the number of families due to some extinction event. And when you study the fossil record, they've worked out, the kinds of species particularly, and roughly the percentage based on the fossil record that became extinct. So you've got the Ordovician extinction here. 50% of animal families, including many trilobites, appear to disappear from the fossil record. The Devonian extinction here, 30% of animal families, including many fish and trilobites, disappear from the record. The Permian extinction is huge. 60% of animal families, including many marine species, insects, amphibians, and all remaining trilobites, disappear out of the fossil record. So there are no trilobites after this period. Triassic extinction, 35%, including many reptiles. The Cretaceous extinction, 50% of animal families, including the last of the dinosaurs and many marine species. Now, many of these extinctions probably relate to asteroid hits, comet hits, which have probably changed the very nature of the climate on the planet, which has affected multiple food chains and food webs, and indirectly has animals have not been able to adapt fast enough to the massive and relatively quick changes, which still could span thousands of years, and therefore have become extinct.